Dear ladies and gentlemen, welcome to today's webinar about cutting tool coatings by Bernix and by Hauzer. My name is Michiel Eerden. I am the Director of Sales at Hauzer. I will today only give a short introduction, after which I will give the word to Philippe Reclin of Bernix and to Louis Tegelaars of Hauzer, who will explain more about our technologies. Today we plan to show you that the Swiss and the Dutch, we know a lot about cheese, but actually we also know a lot about coating technologies. And with our broad range of technologies that we both have to offer, we can be assured that with the complementing technologies, we can help you, we can assist you to bring you a solution, a cutting solution, cutting tool solution that works for your specific market. We complement each other with our CVD and PVD coating solutions. And this is the message we would like to bring today. With these broad range of technologies that we have to offer, but also with our flexible mindset, we are committed to make sure that we help you be successful in your specific market. That is quite important to know about Hauzer and Bernix. We back that up by worldwide support. We have offices worldwide, and we are growing in this direction as well. Customer support, as I always say, customer support is not a department, it's a mentality, and this mentality is also living within our companies. And that is how we back up the success of your company when you work together with Hauzer and with Bernix. So with this being said, we have a full program today. So to start with, I would like to give the word to Philippe Reclin of Bernix, and he will introduce more about our CVD solutions. Philippe?
Thank you, Michel, for these nice introductions, and hi, everybody. So, yes, sure. My name is Philippe Reclin. I'm the head of the sales at Bernix since 20 years. And I will have the pleasure today to introduce you about our specific CVD equipment dedicated to cutting tool applications. So today's agenda will be from the CVD side, the product portfolios, some coding results applied to these fields, and the outlook, the future, and the development lab tube machines. After that, I will have the pleasure to give the word to my friend Louis from Hauzer. He will present you the side cutting tools application machines from Hauzer side on the PVD machines with some PVD solutions, coding result as well, and portfolio. And at the end of that, we will have a question and answer where both of us will be very happy to answer your questions. So let's go directly in the CVD fields. And speaking about the portfolio of the product. Of course, we have made the CVD machines since 1973, fully dedicated in construction and design to the cutting tools. The size of the reactors, the work trays, all the construction is really dedicated to the cutting inserts. The fact that we have a dual chamber which allows to make the preparation, loading, unloading in mask times demonstrate that it is the perfect tools dedicated for these word applications. The hoist, which is makes this machine as a semi-automatic tools delivered with a neutralization, which gives the machine the possibility to be totally free of environments. The point important is that we are dedicated these machines to a multiple variety of coatings. TIN, TIC, TICN, MTTICN, which, by the way, is a technology developed in the 80s, 90s by Bernix. As well, aluminum oxide with different crystallographical structures, alpha, kappa, and the texture today. And one of the last one, which is TI-LNN coatings by CVD. Again, the work tray, which are specific to that, and the field of pressure of the machine, which are moving from 5 to 800 millibars. This machine then effectively allows us to have all these nice spectrums of coatings from, again, TIN, but also including hafnium, zirconium, tantalum, some versatile elements in the modules, in the module of the machines, and hardware and software integrations. To integrate these modules, of course, we are speaking about applying the different precursors. Gases like HCl, BCl3, ammonia, CO, CO2, CH4, mixed with liquid precursors, which are TiCl4 and CH3CN for the empty CVD, for instance, but as well SiCl4 to bring the additive silicon element into the multi-flexible coatings. Of course, the solid precursor with aluminum, hafnium, zirconium, chromium, tantalum. So all these products, all these precursors, make this equipment to be a unique and very versatile tool to apply different solutions for our customers. So we developed for on the market, on the shelf, but also to find the solutions to bring the coding facility to our customers. We are really the, as I would say, and I take a word from Louis, enablers, making this portfolio of applications dedicated to our customers. So I will give you 3 examples of applications. And the first one here, it's an application for customers. So to well understand that we build a machine with upgraded, but we also supported our customers with the time, live, and the development of the applications. We had a customer coming back to us and having buy us an equipment by a couple of years ago. And we were dedicating some standard coatings, CVD coatings. And after a couple of 4 or 5 years, we have this issue with this customer to be far from the benchmarks. And to allow him to bring back the machine to be a tool that he can use for the actual needs, we participate with him to development campaigns where we had different campaigns of test and increasing of the performance of the coating. So we did it by making new different multi-coating layers, improving the fine-tuning, improving the adhesion from one layer to the others, going from the TIN, MTTICN, aluminum oxide, and not only here about the texture, about the crystallographic texture, but also the texture itself. And so we slightly went to bring back from 70 to 75 to 84% of the performance on the tool to the actual benchmarks. The last improvement, we also made it thanks to the fact that we were also working on what we call the pre and the post coding operations, which helps to definitely bring back the application to the level of the benchmark. To illustrate this pre and post coding effects, this graph here explains well what by a standard codings, where you see that with nothing just by the coding, you have a weak time life, where you can increase the time life of this coding by 10 minutes in time life by just post operations. By choosing the right dedicated coding multi-layer aluminum oxide and texture, you can then jump from this stage to this stage, which is a 30 minutes, which is a huge improvement of the time life. And the last post and pre and post operation can even enlarge more the performance of these tools. So this is making in combination with our customers. These are things that takes times. This kind of program can take from 6 months to a year. It allows us also to upgrade our equipment, which we are fully able to do. And one of the good illustration of this is this last TILN codings. This was worked out by a German institute with EOMs, and they at the moment came back to us saying, okay, we find something nice, but this something nice with the TILN codings needs to work with some new materials, new precursors, and working with a pressure field which is not usual. Are you, Bernex, able to do that? So we had the the happiness to say, yes, we know this precursor, we know how to handle with these pressures, and that's allowed us to propose already a hardware upgradable with software technology to those customers who develop these technologies. Here you have an illustration of one of these early coding that we did for one of our customers, where each uses his best PVD and CVD reference, and you see that already this TILN was enabling to double the performances of this coding. So this is what really is the aim of our organization, is to continue to work on the development of the tools, to upgrade the machines, and to participate to the innovations. So now what's coming next to bear next? Because it's always a step to think about. Increasing the deposition rate, that's what we learned with this TILN. We learned that with different precursors, we are able to increase the deposition rate. We were used to speak about 1 micron per hour for aluminum oxide, and with this ALTIN, we get to 2, 3, sometimes 4 microns per hour. Increasing the coating homogeneity. So 20 years ago, when I joined this company, we were speaking about homogeneity or distribution of plus minus 20%. 10 years ago, with changes on our hardware and software, we were able to go down to plus minus 10%. And today we still think that there is room to still improve that. So these two elements participate to improve and to increase the productivity, but not only. You have some hardware development that we are hardly working on, which can participate to develop that as well. So increasing the flexibility, the operational flexibility by automations of the layout and the design, that participate also to the evolutions of our equipments. And just to close the loop, lowering the coatings temperature, because that's what the TILN learns us to apply. We are looking to apply that for all the standard or the coatings. So one of the last things I wanted to present you is here another machine, which is our lab tube, which is totally an R&D machine dedicated to allow the R&D department of all our customers to work with a brighter portfolio of application, of natures, of substrates, different than the one which exists on our equipments. And I think that's what I wanted to shortly introduce you this morning. And now I'm pleased to introduce you Louis from Hauzer, who will give you and present you what Hauzer is doing on the PVD side. So Louis, please, the table is yours.
Thank you, Philippe, for the nice words. I would like to welcome you all to the seminar as well. My name is Louis Tegelaars. I'm a product manager for a couple of years now at Hauzer Techno Coating, and I will tell something about PVD technology, where the PVD stands for physical vapor deposition, and where Philippe talked about earlier was CVD, and that stands for chemical vapor deposition. So I want to re-summarize a little bit where I'm going to speak about. So we have some PVD solutions, some coating technologies. I want to discuss some results and test cases with customer, and I want to show you the product portfolio we have. So in this technology portfolio, you see a lot of different technologies available. And in fact, we can combine technologies in a machine. Not maybe all of the technologies in one machine, but we can add a lot in one machine. For the coatings in the tool business, there is several things which are important. So that's the one here is circular arc coatings. That's famous in the world of the tools. We developed our own circular arc called Flex. So we have higher output, higher currents on the surface, and therefore with splitting the beams we can still have a smooth surface. So the next one, development in this case, is something I would adjust later on as well. It's called pulsed arc, and this pulsing even decreases the roughness even more. So the other important things in tools are magnetron sputtering and, for instance, high pimps. So high pimps is also a magnetron sputter technology, but it's a new generation. And together with dual magnetron sputtering, this can have the combination of nitride coatings and oxide coatings. That's for the cutting tools. For forming tools, we have still plasma nitriding, and that you see here on the right hand. That's good for having a base layer where the structure of your coating is much better. Furthermore, some other cleaning technologies which are also important. So if the product is not clean, really clean, then the coating doesn't stick, and at the end of the day you will have a malfunctioning of your coating. So for an example from a customer, so for the time being, E-beam technology was widely used for tapping industry and still used and very much used. It's a very good coating and mainly produced titanium nitride and titanium carbonitride. In the slide next to it, I will show you that high pimps coatings can have some other benefits of these E-beam coatings. What is high pimps? High pimps stands for high ionization magnetron sputtering. What is high ionization? Where Hauzer focused on the development is we want to have high ionization degree and a controlled discharge, meaning that the sputter rate still keeps high. You do this by programmable pulsing, and that you can do that with block shapes, with deep oscillation magnetron sputtering. It's called DOMS as well, but also with pulse width modulation. Pulse width modulation needs a little bit more explanation. So you have your pulse with the normal pulse, and on top of that, you can program a train of pulses, and with doing that, you can adjust all the, let's say, parameters of a coating. So you can influence the internal tension, you can influence the build-up of the coating itself, and therefore have some new, renewable, programmable things put in a coating. There is so much parameters at the moment that even for us it's undoable to have all these parameters available. We can have this high pimps technology for tool coatings on a FlexiCoat 850, on a 1000 system and a 1250 system, as I will explain a little bit later. And most advantage is that we can combine this technology with other technologies. So you can combine ARC with high pimps, dual magnetron sputtering with high pimps, whatever you want. We can discuss about and think about what the ideal solution would be for your tools. So some examples, in this case for a tap. Tapping, okay, as already said, titanium nitride, E-beam, that's the standard for a couple of years already. I think even more than a couple of years. So people are starting, hey, this E-beam technology is old-fashioned and we want to start over with new technology. And you have this tapping material, you have the tool or the material where it's working in. So what we start is, okay, we want to do a high titanium nitride with high pimps. Titanium nitride works. High pimps is a new technology, but titanium nitride is one of the first coatings and therefore maybe already a little bit old-fashioned, but okay, works. You see here that on the first step you have about 800 holes, and the second step with the high pimps titanium nitride you get to 1100 holes. But we thought, okay, if you can do this with titanium nitride, why shouldn't we take another material, for instance aluminum chromium nitride? And if you do aluminum chromium nitride with high pimps, you see immediately a big jump to 2000 holes. And that's only on a material which is not post or pre-treated. So probably there is more space to increase the productivity as well. So another tool which is compared to, and then we compare from a well-known German manufacturer of tooling. So the top two lines is the reference from this tool manufacturing itself. He does his own coatings on, let's say, equipment from competition. They are not bad at all, but they said, okay, could you please try what your standard coatings will be? So the first shot, and you see this is the Shark Plus line in the middle. That's already better than what they have in-house. But the high pimps is even better. So what you see, 2 different coatings is already better than what they have in-house at the moment. This is not something which is always realistic. So this is a one-shot luck. But normally we will develop, as Philippe also told us, that it takes a couple of months to develop together with the customer, put a coating, do a wear test, see how the wear is going after machining, and from that point renew the coating design and do a new test. So the second one, where I already talked about a little bit, is pulsed arc. This is the latest member of the technology portfolio. So with pulsed arc, we try to lower the droplet density and roughness compared to the CR Plus we already have. So we do that with highly ionized metal plasmas, and that means that the deposition of the coating is having good adhesion and a high density. What we see is that these various highly ionized metal plasma, they create novel coating properties, novel structures, and new possibilities to make coating designs. So what you see here is the difference between normal CR Plus coating. So you see the droplets over here, and this is the one with the arc but pulsed, and you see much less droplets. So this is better for when it works in a metal sheet. So the lower the roughness, the better it functions, and the lower the roughness as starting point, the less energy you have to put into post-treatment of this coating. So what you see here is, and excuse me, but we don't understand really how things work at the moment. It's so new. But what you see here is a difference in wear mechanism between the arc and the pulsed arc. So you see the wear over here is going from a rough to a little bit smooth transition, and here it is much smoother and starts in a different way. Do we understand it yet? No, not yet, but we are trying to understand it and developing together with customers more and more how this works. In this case, it worked fine, but we want to ask all people outside, please try us, and please also do not expect that the lucky shot will work in once. So try to develop with us and see if we can put this pulse arc technology up front. So then we come to the product portfolio. So of course, coatings are important, but the equipment where the coatings come from are also important. These equipment should be reliable, should be productive, should be easy to maintain, and all kind of things. What you see here is a FlexCoat 850. This FlexCoat 850 is the smallest machine, especially for chef shank tools. This machine has 4 flanges, so we can put in 4 different technology if we want. It has a table diameter of 500 millimeter, a table height of 500 millimeter as well. That is the homogeneous zone of the coating. The 1000 has 6 flanges, so it means that you can add 6 technologies inside. And the 1250 has the same number of possibilities. So you have 2 doors. You don't see them open here, but you can open the doors widely so you can touch everything inside the machine very easy. The weight here is about 1,000 kilograms, the height of the coating zone 650, and the diameter of the table is also 650. And then we have a large workhorse, the 1250. The principle of the design is the same as 1,000, also 6, even 7 flanges. 810 millimeters diameter and 850 millimeter of coating zone. So then I would like to introduce Philippe Priclin to stand with me and see if what questions do we have.
So I have a question here, which is interesting. Can I explain more about low pressure advantages? So lower you're going in the pressure, less you are introducing gases and faster it goes. And you can actually tune different materials. And the low pressure can also contribute to have you different texture or adhesions on the coating. We learned a lot with TILNs, which is the first one. We are making some works with low pressure other elements like aluminum oxide and things like that. And it brings some inputs. Actually, there is none that I know developments, but I'm sure that the big EOMs are working on that. And we are always pleased to work on developments with our customer on that. So I hope I could contribute to give an explanation or to answer that question.
We have another question from, I hope I pronounce it well, Takanori Sugiyama for Philip.
So is it easy to make the product development by CVD lab tube with normal BPX? So that's the right question. It's the lab tube is another approach. So usually when you are making developments, you are looking to make development on the production machines. And this allows you to apply directly this development to your productions. Unfortunately, CVD technology are not homotetics. And going in a lab tube, you will be able to make a more large spectrum of elements. But it's true that it's not because you have found a good mixture of multi-layer that you will so easily or even be able to bring it to the production machine. It's really another approach to make the development. Making a development on the production machine limits you to the elements that you have on the machine. Here with the lab tube, you totally extend the field of application.
So I have here Philippe Lopez Diaz. Thank you for the interesting talks. Is it possible to deposit TAC coatings using the pulse arc technology? And how are the mechanical properties compared to normal arc? In principle, yes, it is possible. What we see on the nitride coatings till now is that the mechanical properties in hardness and stuff like that is the same. Coating time is the same. Of course, roughness is much lower, but TAC, that's the interesting coating. Normally, it is not applied as a very thick coating, so the roughness is intrinsically already a little bit, let's say, not that important, but we can do it, and it probably has the same function and how we call it, properties, but we have to find out in detail. But for sure we can try to develop something with you or offer you to put a coating on one of your tools.
So we have Mirko Z that asking the question, are you also doing DLC coating by PVD or CVD? So by CVD, we don't. We stay to the high temperature CVD, but you do in PVD?
At PVD, in fact, a DLC coating, at least the DLC coating as known now, that's, we'll say, an in-between coating between PVD and CVD. It's called PE-CVD. So yes, we do DLC coatings by PE-CVD. You can put it into the machine. So if you have a machine which is capable of doing DLC coatings, then you can do magnetron sputtering and PE-CVD, have your DLC coating.
Hi, Kevin Khan from Taiwan. So is the performance of the CVD TILN better than the CVD aluminum oxide? I think you cannot tell that like that, Kevin. It's really dedicated to different applications. And for some application, yes, it's demonstrated that CVD TILN in milling application outperforms CVD aluminum AL203 or even PVD. But it's not only the case. It really have to be a case by case. But most of the time, yes, when the advantage of CVD TILN, it really outperforms the results. The famous German brains show that they multiply by 2, 3, 4 until more times the time life of the cuttings operation by applying this TILN.
Then GM Neilish, you mentioned about some pre and post operation in PVD. Can you put more focus? Yes, it's well known that that's not only for PVD but also for CVD. Pre and post treatment of coatings are important. So the coating solely, that's of course interesting, but the tool design, the pre-treatment, coating and post-treatment, these are all important. What you see is that you have different pre and post-treatments for different applications. So that will go from dry blasting, wet blasting, brushing, polishing, you can name it, but it's very hard to have a general remark about this post-treatments. But maybe we can discuss later on in a face-to-face meeting or on a webinar or on a team meeting or stuff like that to explain a little bit more. Can you explain more about the possibility to add different technologies now and maybe in the future? So that's where and I think it's same counts for Bernex. What we do is we have a machine which has the current technology on board, and we build it in a flexible way. So with components which we can extract from the machine and put in new components. So we do that already for a lot of time. For instance, our machine in the competence center is already rebuilt about 15 times from one technology to another, from one set of power supplies to another, from whatever we do. So if you have a technology now, so we always can put new technology, which even we do know now at the moment, but we design with the way, okay, this is the flange size, this is the flange size now, and this is the flange size in a year, and in 10 years, and in 20 years. That's the way how we build our machines, that we can put in new technology.
So to both of us three, can we explain about more about the joint development possibility and what is the competence centers? So the first thing is that since we are under the IHI roof and that Hauzer is totally taking care about PVD and Bernex totally about CVD, we can really each of us concentrated on these two fields, which, believe me, can take your life already to develop the coding. The advantage is that we have two entities we are 700 kilometers each other, so can still speak each other and compare and combine by common meetings, technical sales, what are the tendencies, the trend of the markets, where one of us is probably having some more difficulty to develop, bringing the expertise of the other one.
So the competence center, and we have both. That's where we have a basic machine with a lot of possibilities. And not only the machine is important, but the competence center is also having process engineers. These process engineers not only go in this competence center, but also go to the customers itself. And together we discuss and fine-tune the coatings we have in mind. So in the competence center, you can have a look, you can visit us, we can coat the tools you have on the moment you are visiting us. We know we have a limited amount of laboratory facilities, because if we would have a huge laboratory, most of the stuff was standing still. But we know our way to universities, we know our way to research institutes to see, okay, what do they have as a measurement equipment. So bundling all that together can give you the advantage on your tool to have a good performance. Then we have Yao Konzu. I want to know more about pulsed arc. How about the deposition rate? Is it possible to deposit the oxide coating? Pulsed arc, we can have a discussion in person as well in this case. If you really want to go deep, the time is too limited now. Deposition rate, what we notice from one coating to another, we don't see any difference between arc and pulsed arc. So is it possible to deposit the oxide coating? To be honest, I don't know. I'm not sure if we tried it. Is it technically feasible? I guess so. Is it interesting commercially? I don't know. We have to discuss about and see, okay, what do you see? How do you see it? And maybe we can work out something together.
Okay, Kevin, thanks for this other question. The thickness uniformity of the CVD coating is plus minus 10%. Is it in the batch or between the batch? So it's within the batch and between the batches. And this is something that we have developed 10 years ago, and we were making what we call CMK, realizing 50 of batches, repeatability one after the other, and the development of the better temperature distributions, controls, software and the hardware showed us that we had a growth curve that allowed us to pretend that we are really within the plus minus 10% from one batch to the other.
I have some questions, or multiple questions from Loris Chavet. Hello Louis, could you please explain what's E-beam? What's the difference with regular high pimps? E-beam, that is a quite old technology where you use electron beams for the evaporation. So it's also called ionization. No, not ionization, ion vaporation. This is a way of making a melt, and it's quite different than from the normal sputtering. So where you have high pimps, you use a target in the side of the machines, and you use pulses. That's nothing. With E-beam, you don't use pulses, and the E-beam technology is more or less starving as we see it now. That's all done with high pimps. The next question, is it electron beam evaporation? Yes, of course, that is. When you compare the number of holes for SARC Plus and high pimps, did the coatings have the same thicknesses? Also, what deposition rate are you able to reach using high pimps? The speed of SARC Plus is still much higher than the speed of high pimps. That's for sure. What you see nowadays is that the advantages of high pimps are more or less the disadvantages of SARC Plus, and the advantages of SARC Plus are the advantages or the disadvantages of high pimps. So I think that continuously developing will go to get rid of the disadvantages of both technology, and somewhere in the future they will be equal, more or less.
Yeah, I see. The question about explaining some details about the low pressure CVD. The low pressure CVD is a consequence of the development of the TILNs, and that's opened us the door of a new field. For 20 years I was in this business. I am in this business. We were working with pressure going down to 100 millibars. We were working with temperature down to 850 degrees. We were working with precursors, giving us the possibility to make deposition rates by 1.5 micron per hour. And these TILNs CVD developments allowed us to lower the pressure, to oblige us to lower the pressure, to lower the temperature, to increase the deposition rate. So we learned a lot. It totally opened the door for us in the research of developments, and the low pressure make that you are probably making some more dense coatings, which can probably explain their better performances than the higher, I would say, pressure coatings in the market. That's the reason why we today try to transfer all these let's say standard coatings to this low pressure environment as well.
Then I see a question from Brazil. Hello, Fernando. He says, hello Louis, what is the best solution in your experience for TCT, circular saw and HSS circular saws? We know a lot about PVD, but is there a chance in CVD coatings? So in fact, the question is more or less for Philip, but to my opinion, but Philip can support me in this one. The flatness of a circular saw is increasing, is very important. With CVD, you go to a much higher temperature than with PVD. So, are you able to get the circular saws flat with these elevated temperatures? Frankly, I don't believe it, but maybe you can make a statement, Philip.
It will be very challengeable.
Yeah.
In fact, at the end of the day, I don't know an application for saw with CVD so far I can remember. But if you could imagine one, the post-operation, the redoing of the heat treatments will just make the thing that much more expensive. That here the right answer is for sure the PVD one, for sure.
So next one, maybe also from Fernando, I don't know. Philip, can you say something about CVD on forming tools as well?
Yeah, you have some good application for forming tools, especially when you have a forming tool where you have to deal with intense stresses. Probably here, most of the forming tools, it's dedicated to the field of PVD. But here for this high stress operation works, CVD is probably the better answer. This is really here a field where CVD and PVD can complement each other's. And it could be a case by case, and we are used to very often exchange between us the question of this or that customers, and bringing some guy coming to the CVD, directing them to PVD and vice versa.
Then it says, Louis, can you explain TEC? How can it be produced? What is the application? So TEC, that's a really special coating. It's a carbon-based coating. It can be produced by, it is produced by PVD, and we have a lot of different technologies in house where we can produce it with. It can be with CARC, with the old-fashioned CARC, with CARC Plus, Pulse CARC, and even with high PIMs. So where you see the application is mostly in the field of non-ferrous metals. So cutting aluminum, cutting copper, this kind of things. The most important feature of this TAC is that it prevents material from sticking on the tool. So the coating itself is very hard. We can produce it up to, let's say, 7,000 figures. And if you know diamond is 10,000 figures, you can imagine how hard it is. For most of these applications, it is very important that the cutting edge stays really sharp. So it's a matter of, let's say, having a thin coating to still have the cutting edge really sharp, but thick enough that the parts or the small particles from the aluminum don't stick at the surface of the drill or the mill or whatever it is. The Pulse arc was already tested in circular saws, and this technology is available in the Flexico 1250. The Pulse arc technology is available in the 1250. Is it tested on a circular arc? On a circular saw? I am not sure, but I will come back to you to this in detail, Fernando. I have to sort out. This is the end of the questions. No questions anymore. Then the only thing I would like to do is, please, if you want to learn more from both Philip or me, you have our contact details in this presentation. There might be some questions popping in, but that we can answer on that one separately after the webinar.
Yeah, we will be pleased with that for sure.
So I would like to thank you all for your attention, and hopefully see you soon at Hauzer or at Bernex.
Thank you.